let's do example 3.2, which is identical to example 3.1. Is you need to figure out the slope of the tangent of the graph of f of x equal to x squared at x equal to 3, which is identical to the previous example. So why are we doing the same thing again? Because we want to use the other formula, the formula that's slightly different. That is this thing. So before we used the slightly different one, and now we use the one that has h in it. That is the tangent. Here's the formula we need to use. Tangent equals the limit as h approach 0 of f of x plus h minus f of what was it, x or h, something, okay, over h, f of x, I believe. Okay, here's the formula we need to follow, which is identical to the one before, but which has a in it, but now we don't need to do it again. So why are we doing this again? Because this formula is significant in the definition and understanding of the derivative. So is well, normally I don't do grunt work, as you know, but in this case I will do it for your sake, to improve your understanding. So let's do this, and it's fairly straightforward. You follow the formula, which says, so you so in this case x equal to 3. Did the formula say f of a? I think it might have said f of a, because x is at a. So let's change this slightly and call it a. What did the formula say? Okay, so following the formula, in this case where a is 3, so that is going equal to the limit as h goes to 0. You notice you're dividing by 0 again. So as h approaches 0 of so f of 3 plus h minus f of 3 divided by h, which equals to what? Okay, now put it in. That's limit. F is x squared, so we have 3 plus h squared minus f of 3, which is 9, divided by h as h goes to 0. All right, and then you keep working on this stuff. That becomes well, square this thing from algebra. You get something like h squared plus 6h plus 9, and then minus 9. That's very convenient. Got rid of that. And then so you get, here's the limit. Don't forget the limit. And then so you have the 9 it disappears, and then you have h times h plus 6 divided by h. Okay, here's where we cancel out the 0, because we're talking only about the delta limit. I mean the delta neighborhood of where h is close to 0 but not 0. Okay, so then you get to cancel out the h. So then that becomes the limit of just as h approaches 0 of h plus 6, and well, h goes to 0, that becomes 6. Now that's the same thing we did earlier, but it's good to work with this the slightly different formula, because the slightly different formula features the fact that your denominator, which is called the increment or something, is going to 0, because and that's how the derivative is formed. The derivative is formed by calculating the slope of a very small point. You have a very small triangle there where you have to calculate the rise divided by run, but both are very, very small. So you calculate the limit, and it actually gives you some kind of a reasonable answer. Instead of just wave your hand and say, I don't know how to divide by 0, forget it. This is where Sir Isaac Newton is brilliant, is that when you can't divide by 0, let's look at the stuff around it, around where h is 0, and see if that becomes something. Okay, that is that. Now, the next examples, 3.3 and also 3.4, I am going to assign it as homework because they're fairly straightforward, and I don't want to spend too much time doing that. Now, and in general, any examples I do in the video class, you should redo it before you do your homework. Now, if you say, oh, I have never done any examples the professors do, it's not too late to start now. All right, but in this particular case, the example is part of your homework, so please make sure you do it. So that's I will write that down later. Example 3.3 and 3.4. What you do is you write down the problem, then you don't look at the solution in the book, and then work it out yourself. See if you can get it, without looking at it. And of course, if you get stuck, there's the book explanation right there, very convenient, which is why I highly encourage people to redo the examples in the book that I consider valuable. So, so moving on, we're on page 220. If we'll write down that page, whatever. So, but right now we're on to page 220. If I can find my marker, that would be very good. What did I do with it? Okay, give me a second. Couldn't find the marker anywhere, so I had to get another one. Doesn't matter. Now let's go to page 220. Now that's the expensive marker, that's the cheap marker. By a little bit, I guess. Let's see which one's better. So let's look at page 220, where we have the definition of the derivative, okay? And the derivative is the first half of calculus. You have calculus, you have differentiation, and you have integration. Now we officially enter the derivative. What is the derivative? The derivative is the limit, is this thing right here, the slope. And yeah, we have it written here already, but we'll rewrite it here. The two forms that we've been learning so far. The first one is f prime a equals to the limit as x approach a of f of x minus f of a divided by x minus a, I think is the way to say. And then similarly, I'll rewrite that one also. The derivative is also by exchanging x, by making x equal to a plus h being the variable here. So by changing that, we have let's write this down. Limit as h approach 0 of f of a plus h replace x, minus f of a, which doesn't change, divided by just h, because you have a plus h replacing x, so a plus h minus a is just x. So this is just a slightly different way of saying that, but maybe I should stand over here. So this is just a slightly different way of saying that same thing, but it matters quite a bit because it changes the way you look at it. This is calculating the rise over run, right? This is the slope. And whereas this is calculating the incremental ratio. That is, f is, calculating value of f that's off a little bit by what it was starting point, dividing by the distance. Yeah. So example 3.4, as I mentioned earlier, I would like you to do it in your homework. So moving on, I should mention that for example 3.4, what you're supposed to do is you're supposed to calculate the the values of a simple formula. See, like this. You can see it in your book. And you say, well, how am I going to do that, right? You have to plug in the value in the chart, and then stuff comes out. So you can, of course, use your TI-84. But I recommend that you use the spreadsheet. There's a free spreadsheet that's very good online. It's called the Google Sheet. It's made by Google. If you Google it, you'll find it right away. And if you don't know how to use a spreadsheet, it's very beneficial to learn. It takes maybe 5 minutes, maybe less. Not, by the time you find the YouTube video that shows you how. But you don't need to learn some. The spreadsheet is quite fancy, but all you need to learn in a spreadsheet is how to type in some formula, and then how to use it. What happens when you type in the spreadsheet is once you type in this column of numbers, right, and you type in your formula there, then you just click the mouse and drag it down. All the answers will pour out, in case you didn't know. So, let's see the TI-84 top that. Not going to happen. So the spreadsheet is far superior for this type of thing. But if you're obligated to use the TI-84 for some reason, then it works too. Much slower, of course, because the TI-84 is not going to be able to come with this now, is it? But it is able to reuse a formula so that you can input it slightly faster than the old-fashioned scientific calculator. Yeah. Anyway, so that's that. Now moving on, let's now that we know what a derivative is, here's the big fancy definition. Let's do something about it. That is, we'll find the derivative of something. Okay. Do I have enough space? Yeah, let's say we do. So we're doing example 3.5, which is next to page 220, maybe a page later. So let's look at example 3.5. Find it. We have a function, and then 3x squared minus 4x plus 1, which is just a generic quadratic equation. And then you're supposed to find the derivative at 2. Alright, remember that I forgot to mention this thing here is called the prime. Is used as derivative. It's not the only way to denote derivative, but for now we'll use that one. Okay, it's called the prime, I believe. F prime of A. Whatever it's called. The point is, we will calculate the derivative, and we'll use the first formula, this thing. So what you do is you plug this whole thing in, you do a bunch of grunt work from algebra, basic algebra, or pre-algebra or something, and then you come up with some stuff. So that we will go ahead and do that. And so we are calculating f prime of A, which is in this case 2. So we will plug everything in like it says. So that means it is f of x, which is just the formula itself. We'll copy that down. Minus 4x plus 1. And then minus f of A. Being that A is 2, f of A is this bunch of numbers. So I'll write it in here. Okay, what is f of A? So you evaluate A. 3 times 4 is 12. Minus 4 times 2 is 8. And then plus 1. Alright, and we'll figure out what that is in a little bit. And then divided by x minus A. No? I said A is 2, so x minus 2. Alright, so so you got that. And now we'll do pure algebra, where you have to come up with something. So we round up the stuff and have something like 3x squared minus 4x, because there's no more x's on top, and then crank out the numbers. 12 minus 8 plus 1 That is what? That's 4 plus 1, right? 5. Minus 5. Okay. Yeah, remember in algebra you have to keep very careful track of the signs. If you mess up anywhere in here, your whole problem is shot. And well, when that happens, start from the beginning. It happens to me a lot when I was studying calculus. You know, you forgot the minus, forgot the plus, or something. It's just something you have to put up with. So anyway, x minus 2. Okay, now we will factor the good old factoring tricks of algebra. Let's factor. Doing that thing. Yeah, well, being that there's an x minus 2 down here, chances are there's one up there because you're going to be canceling out the 0 later. So, alright, so then 3, we have 3x and x, and then there's a name for this thing, but we're not going to, I don't remember what the Americans call it. And but anyway, you have to come up with 5 here and 4 here. So 5 is just 1 times 5, so it's probably 5 here. And what? Wait a second. Sorry, there is this is minus 5, but I forgot the plus 1, so it's actually only minus 4. Otherwise, like, why is it 5? Goodness. So let's do minus 4, which will look much better. So if it's minus 4, then we'll have a 2 and 2. And then we'll have a minus and a plus. And so then you have 3 times 2 is 6. And then minus 6 plus 2 is minus 4, which got you this. Okay, so then remember we still have, do we have the limit? Did I need to write? Yeah. I forgot to write down limit, but there's a limit here. Okay, there's a limit here. Limit here. Alright, so then we cancel that out. That equals to limit. Well, where we'll go? Yeah, x is approaching 2 of this beautiful cancellation, right? So then you end up with 3x plus 2. And why is it so beautiful? Because now you don't divide by 0. Now you just you have a nice clean number as x plus 2, and this approaches 8. And that is your answer of what is the derivative of this function at 2. And you think, well, that is quite a bit of work, grunt work, right? And it is, but it gets better. We will, in the next section, we will go through tricks of derivatives so that you don't have to do all this grunt work all the time. But for now, we're just in the beginning stage, so we have to do some grunt work so that it will build understanding. Okay, guess what we have to do now? We are now in example 3.6, and we have to do this exact thing again, but this time with the second formula. This is even more grunt work, but it's important that we go through it one time. Therefore, I will do it even though I don't like grunt work, just for your sake, right? So let me stand over here, and then, sorry, I'm tripping over my cord. So it's the same function as here, so we need to fit this thing into that. So to do that, we will and we're looking for the same number, okay, f prime of the derivative at 2. So let's go ahead and do that. So f prime at 2 equals to the limit as h goes to 0. We're plugging into this formula right now of that problem. So so the first line would be f of Now a is 2, so a plus h becomes 2 plus h minus f of a, which is just 2, and all divided by h as h goes to 0. Next step, next step we need to get this thing in there. And this is where things get a lot of grunt work, but we got to grit our teeth and get through it, because in calculus, as in all life, sometimes you have to just grit your teeth and get through the tedious grunt work, right? So let's do this. So this is the limit. I hope I have enough space. F of 2 plus h, you have to put 2 plus h in this thing. So we follow it. It becomes 3 times 2 plus h squared, and then minus 4 times 2 plus h plus 1. And that's just that part, okay? I put 2 plus h into this function. And then minus f of 2, so you just put 2 in here. And we already calculated what f of 2 is this thing, which is like minus 5. Minus 12 is minus 5. So is 12 minus 8 plus 1, which is 5. So that part we skim off what we did earlier, and then divided by h. And so next, this equal to the limit of, as h goes to 0, now we have to multiply this thing out, which is that's 12 plus 4 times 3 is also 12, plus 3h squared, right? Yes. Well, let's hope it's correct. And then minus 8 minus 8h minus 4, all divided by h. Yeah, we're doing effectively the same thing we're doing over here, but this particular way we get more stuff that has to be cleaned up. So anyway, so keep going. This equals to, now we are deep inside the belly of algebra and has to dig our way out. So that's equal to 3h squared. That's plus 12 minus 8 is plus 4. What? Okay, there's a mistake in here. Now, 4 times h is only 4h. Why did I say 8? There, let's fix that. It's only 4h. That's much better. So 12 minus 4 is 8. Okay, that's looking a bit more pleasant. And then we have, and then the numbers, minus 8 minus 8 minus 4 is minus 12, and then there's a plus 12 here, so it all disappears. As we expect it will, because we can't have a number here, because we have to get to, we are going to be divided by h, which is going to 0. So we're hoping to God that this will cancel out, and it does. Now, isn't this awesome? Look how beautiful it is. It is. It looks complicated in the beginning, but it all cancels out. So then, when you cancel out the h, and then let h go to, so that equal to, well, first let's cancel out the h. So that's limit of 3h plus 8. That's it, because we cancel out the h, because h is going to 0, but it is not 0, right? We continue to emphasize that point. That is the beauty and the intelligence of the derivative. So then remember, h is just going to 0. So at this point, our life is becoming easier. It's slightly more harder up here, but gets much easier here because h is just going to 0. So the answer is 8, which is exactly what it says over there. See, it's just two ways of skinning the cat, and both ways the cat is properly skinned. Okay, now the next thing we're going to mention is the velocity. Now the word velocity is a physics word that means speed. Now what is speed? Now back in 5th grade math, you learned that speed is calculated by distance over time, right? And this is how far did you travel. You calculate how far you traveled by seeing where your new position subtracted by your old location. That gives you the distance, and you calculate your time difference, and that gives you the speed. Now in calculus, we calculate speed at a very small incremental place, and we call it the derivative. Therefore, as for us, the velocity, meaning speed, is equal to the derivative of the function. Having said that, that is all I'm going to say about this chapter. There are more examples, word problems, that I believe we should skip for now because we are just barely starting to develop the derivative. There is a lot more coming. So for now, I don't think we should waste our time doing the word problems. We'll do it very soon, and there is a truckload of it coming. Trust me on this. So for homework for today, please redo the examples that I did, and then do the homework is on page 228. So please do. In this case, the homework includes some examples. So after you do the examples I did, do the 2 examples that I didn't do because they're very similar to homework. That's example 3.3 and 3.4 on page 220. The homework is on page 228. I will write all this down below the video when I upload it. But for now, you can know that it is, you will do 16, 17, 18, 24, 26, 29, 41, and 49 on page 228. So at this point, please go stop the video and go do your homework. And when you're done, come back and I will talk about it. Actually, this section of the homework is still pretty basic. You're doing quite a bit of grunt work, actually. But don't worry, you're not going to be stuck with grunt work forever. Calculus get a lot more exciting than just doing grunt work in algebra. But for now, I will do just one problem from the homework because it's slightly more interesting, maybe. And so let's look at problem number 26, assuming you have at least tried it. So we have f of x equal to square root of x minus 2, and you're supposed to calculate the f prime at 6. Now, I should mention that if you don't have any trouble with your homework and you got through it, you don't need to watch the part of me doing homework because, I mean, it's math. How different can it be? So you can just go ahead onto the next section. But if it's not quite clear and you want to see how I do it, then that's what this part of the video is for. So let's do this thing, and then we follow this formula right here. The first one, which is that thing, right? And we'll plug it all in, which says that so that we need the limit of f of x, limit as x approach a of this stuff, f of x, okay, which is square root of x minus 2, minus f of a is square root of 6. A is 6 in our case, so 6 minus 2 divided by x minus a. So we'll clean that up slightly, which is the limit of square root of x minus 2 minus 6 minus 4. Square root of 4 is 2. And then I mean this is 6, okay? Okay, now over x minus 6. Now at this point, you might first feel a bit stuck. Okay, now what do we do here? Because there's no cancellation No, nothing. At this point, you need to apply the trick that we've been applying, it seems like every single video, and that's called the difference of squares, which I will write it down again. A squared minus B squared equals to A plus B times A minus B. Okay, this thing is your A, and that thing is your B. And there's a name for this trick. I think it's called, specifically applied to something that has square roots. I think it's called a conjugate or something. We don't care what it's called. Okay. The point is, it's just the same trick that we've been using this whole time. So considering this to be A, okay, this is A, the whole thing under the square root, and that's B, and we will multiply it like this. So that equals to limit of you copy down this thing first. So we have square root of x minus 2 and then minus 2 and over x minus 6. And then being that this is the minus, we'll multiply by the plus version. So you multiply this exact same thing. So x minus 2, and then except the difference is we're going to do plus 2. Why? Because that will achieve the difference of squares effect and get rid of the radical sign, the square root. And that's the goal of doing this. This thing is like so useful, right? If you remember one thing from calculus, is probably this thing. Anyway, so let's continue to do this. And we do the same thing here. Why are we multiplying by this? Is to get rid of the square root, but to multiply, we can't just multiply something for the heck of it, just because we feel like it. We need to divide it by the same thing, because any number divided by itself is just 1. If we're multiplying by 1, we haven't changed anything, so the equation holds. So having done that, keep going. Now, at first, this might look like we're making this thing a lot harder now, instead of making it easier. But that's not the case. And that's thanks to the miracle of difference of squares. So now take a look. When you do this, you get this times that, and that times that, and so on. Anyway, the point is you get the square of the stuff. So the answer is you get the square of the square root, which is just x minus 2 itself, okay, minus 2 times 2 is 4, following this particular formula. And then over x minus 6. And look at this. I mean, what is minus 2 minus 4? Now, in the meantime, so you multiply the top out, the bottom is still there, and you can't throw it away. Okay, it has to stay. Because it wouldn't make sense to just trash something just because you feel like it. But we don't feel like it at all. Okay, this thing needs to be there. So that is the solution. And you notice minus 2 minus 4 is minus 6. So this thing cancels out. And so all you got is this thing. And in the meantime, where x is approaching 6, now that chunk is all cleanly, nicely, neatly canceled out. So all you have is this. And x is approaching 6. So you do the math here. 6 minus 2 is 4. 4 take the square root is 2. And then 2 plus 2 is 4. So your answer is nice and clean. 1 is 1/4. And that's how you do this problem. Now, having said that, let's move on to the next section.